Hello everyone, this is Mansi from the Department of CSEI from Sri Venkateshwara College of Engineering. So today's topic is image enhancement in digital image processing. So let's begin with an introduction. Image enhancement is widely used in computer graphics. It is one of the sub areas of image processing. The principal objective of image enhancement technique is to process an image so that the resultant is more suitable than the original image for specific application. So image enhancement, it refers to the process of highlighting certain information of an image as well as weakening or removing any unnecessary information according to specific needs. So what exactly is image enhancement? Image enhancement is a process of adjusting digital image so that the resultant are more suitable for display or further image analysis. For example, you can remove noise, sharpen or brighten an image, making it easier to identify key features. So methods for image enhancement technique can be divided into two broad categories. First is spatial domain methods, and second is frequency domain methods. Again, spatial domain is again further classified into point operations and spatial filters. So let's talk more about spatial and frequency domain. Image enhancement techniques can be divided into two broad categories. First is spatial domain. Enhancement of image space that divides an image into uniform pixels according to spatial coordinates with particular resolution. The spatial domain methods perform operation on pixels directly. So what is frequency domain? Enhancement is obtained by applying the Fourier transform to the spatial domain. In the frequency domain, pixels are operated in groups as well as indirectly. So let's talk more about spatial domain enhancement methods. Spatial domain technique are performed to an image plane itself. They are based on direct manipulation of pixels in an image. The operation can be formulated as g of xy is equal to t of f of xy, where g is an output, f is an input image, and t is an operation on f defined over the neighborhood x comma y. According to the operation on the image pixel, it can be further divided into two categories: point operation and spatial operations. Spatial operation, it includes linear as well as non-linear operations. So what is point operations and spatial operations? Point operations, these processing methods are based only on the intensity of single pixels. Image intensity transformation, first under image intensity transformation, first it comes under image negative. Negative of a digital image are useful in numerous applications such as displaying a medical image and photographing a screen with the monochrome positive film, with the idea of using the resulting negatives as normal slides. Transform function t is given as a g of x comma y is equal to L minus f of x comma y, where L is in maximum intensity. So we can on the left side, on the right side you can see the image where where original image is given, and when negative operation is performed on this image, uh, it is shown below. So we'll talk about frequency domain enhancement methods. This method enhances an image f of x comma y by convoluting the image with linear positive invariant operator. The 2D convolution is performed in frequency domain with DTF. Spatial domain, g of x comma y is equal to f of x comma y into h of x comma y, and frequency domain can be formulated as g w1 comma w2 is equal to f w1 comma w2 into h w1 comma w2. So what is contrast stretching? Contrast stretching is nothing but a low contrast image can result from poor illumination or lack of dynamic range in image sensors, or even wrong setting of lens aperture during image acquisitions. The idea behind image contrasting is to increase the dynamic range of gray levels in an image being processed. So on the right side again you can see an original image, and below it we can see the processed image using contrast stretching. So what are the applications of image enhancement? So image enhancement can be used in various applications, and it can be used to deblur an image, and it can be used for contrast adjustment, or brighten an image, or smoothen and sharpen the image. So image smoothing in digital image processing technique that reduces and suppresses image noises. Commonly seen smoothing filters includes average smoothing, Gaussian smoothing, and adaptive smoothing. Image sharpening filters highlights the edges by removing the blur. Whereas coming to noise removal, noises are introduced to an image at the point of capture from the camera, printing, and during transmission. In terms of image processing, noises can be identified with variance of intensity from the neighboring pixels. There are various types of noises, for example, Gaussian noise, which changes each pixel by a small amount. Salt and pepper noise, it is also called as impulse noise. It randomly scatters white and black pixel over the image. Noise removal techniques reduces the visibility of noise by smoothing the image using linear as well as non-linear filters. Thank you for watching the video.